Hey, this is Don from Padlock Technologies again with another video. This time we're going to talk about FlexVPN, or what I like to call DMVPN Phase 4. Now, before we get into the lab, you're probably going to see something different in the lab this time. I know you guys think I'm going to do EVNG, but got a little surprise for you. This is going to be IKEV 2. Now, normally when you do DMVPN, you're doing IKEV 1, right? So you know, the IKEV 1, you got main or aggressive mode, and then in IKEV 2, you got two phases in it in auth. But the only there's a lot more than just that, but I'll just give you some basic overview of IKEV 1 versus IKEV 2. But what you're actually going to see is virtual templates this time. Instead of just doing tunnel interfaces like you would do in your normal DMVPN phase 1, 2, or 3, we are going to see tunnel interfaces. And what those do is actually create a copy of configurations, and then you will see adjacencies being built on the virtual interfaces. So instead of DMVPN and you're just going through the tunnel and then you create your tunnels that way, you're going to see a virtual tunnel get created. You're also going to see some AAA configurations that are very minimal, but you need us to do FlexVPN. And if you are studying for your CCIE, I would say CCNP to CCIE security studies, you definitely need to know what FlexVPN is. So let's get over to the lab and I'll show you what that looks like. So here's my surprise. We are using CML this time instead of EVNG. Now, this does not mean that I am going to abandon EVNG. CML, I got to get used to because I'd had it when it first came out, which is the CML 1.0 days, or when they used to call it viral. Thank God they got rid of that. This is a lot better than viral. I love the web-based interface. Still, like I said, it's still a little bit of quirks compared to EVNG. The only thing that makes EVNG slightly better is the node count, right? So right now, I'm just using the free model right here because I'm thinking about getting a license. Cisco, hint, hint, throw me a license real quick if you really want me to demo this thing to its full capacity. But you know, whatever. For this lab, I only need 5 nodes. But I'm not playing Cisco. You want me to advertise this thing? Shoot me a license. Um, and you got to talk about that 40 node limit, right? So unless you're creating some real extravagant super labs, you could probably get away with Personal Plus, which is 40 nodes. I know they have one that's like 300 nodes, but that's for somebody that's really like network architecture or pre-sales guy that really needs to build out an environment to show a client or something like that. So you may or may not need that many nodes. Now, for me, the most I've ever gotten to, I think my biggest lab was probably towards higher to the 40 node. So 40 node might work for me, but I'm going to see that's all about first because, you know, if you see my EVNG labs, you know, there are multiple clusters in my lab. I got 4 servers for clustering in EVNG, and then that gives me power to just run ridiculous labs with all kind of nodes and stuff like that. But again, CML is pretty good, sweet. Got to get used to it, but I'm not going to say anything bad about CML. I mean, I think it's pretty cool, especially coming from the viral days. So, with that being said, we have a basic hub and spoke topology. You would probably see this in your DMVPN, right? So you'd have in a real design, you would have 2 hubs because you want to have that redundancy there. So you'll have tunnels going from one hub into to the next hub. You would probably use tunnel keys to distribute the data plane and stuff, or to separate the data plane so it knows exactly where to go. But that's DMVPN. We're talking about FlexVPN here. So what you're going to see in this lab is, and before we even start, what I'm going to do, because I know the console shows up at the bottom, so we are going to just move me up so we can actually get here. So what I'm going to do is I'm going to click the hub first. We're going to look at the configurations there. Pretty simple on the hub. It is the spokes that run a little bit different, but when you see this, and we do the actual ping tests and adjacencies. Now, I believe the adjacencies are already up, but when we see spoke to spoke communication, you're going to see a EIGRP relationship between the spokes. All right. So let's see here. Go to the hub first. Again, see, this is what I got to get used to because you usually on EVNG, you just click and it opens up the console, and CML doesn't work that much. Doesn't work that way. So let's go over here. So first things first, we're going to look at the crypto stuff so you can see the difference. So again, this is IKEV2 plus I'm doing front door VRF. A lot of people do not like doing anything with front door VRF because they always make the mistake in not specifying the front door VRF when they create their policies or create their profiles and stuff like that. So let's scroll up to the top here. Is we have our IKEV2 authorization policy. So this is for FlexVPN because you're going to use AAA in your IPsec in your IKEV2 profile to say, hey, you're going to call this authorization policy, right? And this is going to be also with the AAA. So we got a pool here called FlexVPN. I'm doing DHCP off of this router, so I'm going to assign addresses to my spokes from this pool, right? One of the cool things you can do with FlexVPN. The net mask is going to be a /24, and this route set interface just says, hey, use my interface as the next hop or advertise my interface there. Then we have our proposal here. Now, if you know anything about doing IKEV2 on a router, it's a proposal, then a policy. And normal IKEV1, which is ISAKEMP, you just do the policy and you do all your encryption or your crypto algorithms from there. But in phase 2, you have to do a proposal. Then you need to do a policy that matches the proposal. And that's what we did here. Now I'm using the GCM ciphers. So these are the latest and greatest. Now, the one thing they did not have in here was GCM 192, because normally I would do GCM 256, 192, and 128. Now, if you know anything about IKEV2, it is you can pick either one, whatever matches, right? Now in IKEV1, you'd have to have a separate policy for each different kind of crypto algorithms you want to use. For an IKEV2, you could kind of just line it across, and then whatever matches first is what's going to be picked. So let's say I did GCM 256 and it's GCM 128 on this one, but then I did GCM 128 on the other one, and then just AES on the other one. Well, it would match on the AES GCM 128, and then it would use that for the encryption. The one thing you do not see is an integrity algorithm, because when you use GCM ciphers, the integrity algorithm is already built into GCM. So you don't need to actually specify your integrity algorithm. And to match what an integrity algorithm is, basically your hashing algorithm, like in IKEV1, right? In your IKEV1 policy, you would have a SHA-256 hash or something like that. Well, in an integrity algorithm, it's the same thing. They just called it integrity in IKEV2. Now, the difference is when you use GCM ciphers, you no longer need to use an integrity algorithm because it's built into the GCM cipher. That's why I usually recommend people move to GCM, because it's faster and it already has that built-in integrity algorithm in it. So you don't have to worry about getting that. Now, PFR is kind of like integrity, but you kind of have to put that in there, right? It won't work unless you put the PFR algorithm in there, and they usually match your hashing algorithms. And then your Diffie-Hellman group 19 and 14. 21 is probably going to be deprecated because it's still an elliptical curve algorithm, but the overhead is a lot more than 19 and 14. At the bare minimum is 14 though. Bare minimum, you should have 14, unless you're doing IKEV1s, which you have group 5. And if you are somebody that's still doing legacy style VPNs or route-based VPNs using Diffie-Hellman group 5, you need to change, you need to change that to IKEV2s, or do group 14 if you're allowed to do it in your IKEV1 policies, because group 5 is deprecated now. Now, once you got your proposal, then you go to your policy here. Now, remember, I told you I was doing front door VRF. So when you do your IKEV2 policy, you have to specify that front door VRF in the policy. So you say match the front door VRF, match the address that's in that front door VRF or on that interface that's in the VRF, and then use the proposal of VPN, a FlexVPN. Everything is called FlexVPN to make it easy for you to understand this, right? After that, you're going to do your key ring, right? So you have to do your key ring, and ISAKEP is the key value, right? So this one would be IKEV2 key ring FlexVPN. In normal IKEV1, you're going to do crypto, ISAKEP, key, whatever, address, whatever. So with this, you specify the key ring, the peer could be any name. I just put any for, you know, ease of demonstration, but in real life, you would put something that identifies the router you're trying to get to, and you would never do this all address any. Now with the pre-shared key, this is for local and remote. With IKEV2, that's another enhancement. You can specify what your local password is, and then you can have a different password for the remote side, right? Which would be the local side on the other side, right? So you don't have to have symmetrical passwords in IKEV2. Once you're done that, you do your IKEV2 profile, match the front door VRF, because if you do not if you don't do that, this will not work because it will assume that it's for the global routing table. And since you don't have anything configured in the global routing table for tunneling, it will not work. So you match your local interface. Obviously, the remote address is going to be anybody in this lab. Here's your authentication. Going to use pre-shared. Now, if you did certificates, this would be authentication remote certificate, authentication local certificate. Then you're gonna have your key ring here, Flexvpn. Now the difference here, now this is still stuff you would probably still see in DMVPN, but you're gonna do, an ISACN profile. You're not really gonna do IKEV2 profile because they're different profiles if you're doing phase one. But the difference here in Flexvpn is you're gonna say this AAA authorization group pre-shared key list Flexvpn. That's the authorization profile, and then the list is called Flexvpn, and the authorization profile is also called Flexvpn. That's why you see Flexvpn in here twice. One is the list, the AAA list that's called Flexvpn, and I'll show you that in a minute. The other one is specifying the authorization profile that you're going to use, which is that Flexvpn authorization profile up here. And then you're going to have this virtual template one that says you're going to create a virtual template. So to match this to the virtual template, that's it. Then you create your IPsec transform set, which is your phase two. As you can see, I'm still using the GCM cipher, so I don't have to do the integrity algorithm in this, which is 256. And the mode is transport, because since we're doing tunneling, we really don't want to duplicate the header. So we just completely remove that. And then we're going to say transport mode, do not duplicate the header, right? If you use tunnel mode, it will actually duplicate the header. So you'll have a header, then you have an ESP packet, and then you have the header with the same IP address information or source and destination IP address information in. So it's a waste of time doing that. Just move that ESP behind the after the original header, and then you're done. Then you have your IPsec profile, which is matching the transport set, matching the IPsec profile, IKEV2 profile, and then I'm going to run perfect forward secrecy, which is running Diffie-Hellman group again, and I'm going to run 19 again. You don't technically have to do that because that keying material comes from the original Diffie-Hellman algorithm that was ran in phase one, right? And then you get some keying material that is going to encrypt the data in phase two. But if you want to be, super secure, and I'm going to use quote for super secure, by the way, you would run Diffie-Hellman again so that the keying material for encrypting the data at the phase two level is different from what was done to encrypt the communication at phase one. That's the hub, right? So now if we go to show run AAA, the only thing we did here is we enabled it by using the enable new model or enabling AAA. And then we just said we are going to authorize the network. Flexvpn is the list, and we're just going to use local. So whatever the local policy is on there, right? So if you're used to doing something like just normal 802.1x IBNS 1.0 or 2.0, you already know what these mean. You already know what AAA authorization means for network. You're authorizing the device to be changed by something, right? But this is going to be changed by the local policy and not ICE itself. So but you could use ICE if you wanted to. But in this demonstration, we're just going to use the local policy. Once all that's created, now I did a very simple EIGRP, right? So we just go to router here. All right, very simple EIGRP. You'll never do this in real production, but this is just for the example. And then we're going to look at the virtual template. So we do show run section interface virtual template. I'll just say virtual and I'll find it. Let's do virtual template. Oh, actually, no. We'll do it this way. Instead of doing that, we'll do show run interface virtual template. Come on. One. So this is the virtual template on the hub. So as you can see, I have a loop back on here that is 192.168.1.1/32. So I'm going to just take that IP address. I'm going to do a no split tunnel so that I can advertise the routes from the hub. Anything I receive from the hub can go back out to the other uh, spokes. Now, this is one of the designs of EIGRP. If you do this technically, you need to make sure you advertise the routes down because it's split horizon, right? Distance vectors have split horizon rules. So you have to worry about that. If split horizon was turned on, you would never get the routes right going to the hub and coming back out. So you just got to turn that off. Then we have our normal EIGRP authentication. We have our network ID. We have the redirect so we can start redirecting things. We use the tunnel source as E00. We specify the VRF. Remember, this E00 interface is in that VRF, so we have to specify that. And then we have the IPsec profile that we're using to encrypt the traffic. So that is on the hub. And let me show you IP local. So that's the IP address, the DHCP pool that's going to be coming off of this. So when my spokes are already up, but when they come up, they're going to get something from this IP address. I think site 1 is 10 and site 2 is 11. All right. So that is everything from a configuration standpoint on the hub. So now, if we open up site 2, pretty much the same configurations, but there are some differences here. So first things first, I'm not going to go through the crypto stuff because the crypto stuff is pretty much all the same. But what you will notice, there is a tunnel interface on here. All right. There is a tunnel interface on here. So as you can see, the address is negotiate. So once it gets authenticated via AAA from the hub will assign it an IP address. And this one is .10, I believe. We have our normal AAA stuff. Now you do see some things in here in terms of the MTU. There is a command down here for the adjust maximum segment size. This is to avoid fragmentation because GRE, I believe GRE is 8. It's either 8 or 4 bytes, right? And then you have your TCP is 20, IP is 20, so that's 40. And then the rest is the segment, right? So you want to avoid some fragmentation at all costs. Now, I'm not using GRE technically I am, but behind the scenes. So I did 1360 and then to account for the IP and TCP bytes there, right? And that's just best practice. Now I could probably make it a lot lower to account for any GRE that may be in here. And then it won't fragment the packet. So on certain things, you want to make sure there's no fragmentation. This is just a lab, so you don't really have to worry about that. Then we have I remember when I first learned this command here, this was like a godsend for me because you can do DNVPN the normal way. And then you just, you have to specify, what the multicast and stuff. Once I had this just shortened up everything I needed to do. So basically what this command says is, hey, the next hop server is 192.168.1.1. The NBMA, which is the underlay address, is 10.100, 200.110.1, and we're going to have multicast packets going to it. That's it. This will allow EIGRP and everything to work, right? Then we got this NHRP shortcut, which is going to allow you to do the redirect, right? Or get the redirect message basically. And we're going to use we're going to have virtual template 1 because when we create our virtual template, we want this to actually show up in the virtual template so it can accept the redirect message, right? Because that's what it is. The redirect is just, hey, you are going to do your own resolution, but I'm going to send you a redirect message. If I don't have this shortcut command in here, I won't accept the redirect message. That's why you got the shortcut command in there. Same thing, tunnel source is the different interface here. Then we have the tunnel destination. As you can see, we're not running mode GRE multipoint because we're not really running GRE multipoint. We're not running GRE multipoint at all. We're running things off a virtual interface. So we don't have to worry about GRE multipoint, and NHRP is going to handle the resolution and stuff like that. So you don't really need to worry about doing GRE multipoint like you would do in DMVPN phase 2 and 3. And then we're calling out our tunnel VRF Flexvpn, same profile right here, right? Same profile. So everything, the only difference between the hub and the spokes is there's a tunnel interface. And then let's go show run, let's say interface virtual template 1. This is this virtual template. So we're going to take that IP address that we're going to borrow from the tunnel interface. Same thing in terms of, NHRP, the fragmentation prevention, and then source, VRF, IPsec tunnel. So with all that being said, it's the same thing on site 2. So I'm not even going to show you site 2. With all that being said, if I were to, we're going to bring down the tunnel interface so you can see this come up live actually. So as you can see, tunnel interface is down, right? And you know what I'm going to do? I'm going to bring down this tunnel interface as well. So we can see, so you can start fresh. All right, so tunnel, and we're gonna shut it. Now that's shut down, we'll do here, you show IP routes, IP shouldn't be jack in there. All right, so now we know shut it. So now you're gonna see a whole bunch of stuff happening. So that came up, NHRP came up, the mapping came up, and then EIGRP just came up, right? Because EIGRP is also configured on this, okay? Well, so now if I do show IP route, EIGRP still shouldn't be anything in there, right? Because I don't have anything at the hub. But if I do show there's your neighbors, there's my neighbor right there going off the tunnel. And if I do show IP route, everything you see tunnel, right? Tunnel. I want you to pay attention to that. Now we're going to bring up site 2. And the EIGRP is going to come up there. All right. So now if I do show IP route here, now you see everything is tunnel, right? What we're going to do is I'm going to ping once the routes are there. So we are looking for 2 because 2's on the other side. So let me just show you that. So show run interface loopback 0. So now you see 2's over here. And that's where we're trying to get to, but you see it's being shown from 192.168.1.1. Now, I could have put no hop self on there, but because we have NHRP doing the resolution, I don't need to put no IP next hop self. You don't need to do that when you have NHRP. You do need to do that though when you are not doing DMVPN phase 3. If you're not doing DMVPN phase 3 or Flexvpn, you have to have no next hop self, and you got to turn off split horizon. But now that we're here and you see everything, that route is shown through the tunnel. Now, when I ping .2, 10.255.255.2 from .1, which is on site 1, you will see an adjacency, EIGRP adjacency happen like this, and then that will turn from tunnel 0 to virtual interface, whatever the virtual interface is. So let's ping 10.255.255 to source loopback, and there it is. See, now you see the NHRP resolution reply, and then now you see an adjacency. So now, if I do in the original show IP EIGRP neighbor, you saw it was only one neighbor, right? It was only one neighbor in there. Now, if I do show IP EIGRP neighbors, I have 2. I have one still going to the hub, and then I have one coming off of a virtual interface, which is virtual interface 1. As you can see right here, it does not say tunnel 0. It says virtual interface 1, which it created a whole new interface and copied the configurations over from the virtual interface template. That's why we created a template, all right? So if I go show derived. This is a command to actually see the configurations. Interface virtual axis 1, because that's what it is. There it is. So here is the tunnel that was copied from it was copied from this template here. So if we go show run interface virtual template 1, it took these configurations, created a template, that was the template, and then what it did was just, when that resolution happened, you see it magically changed, it added this tunnel destination to spoke 2. So this was added immediately to the configurations, and that's why you saw that adjacency pop up. So now if we go show IP route and do EIGRP, what you will see is, remember that used to say tunnel 0 because it was coming from the hub. That's what it was originally seen by. But now that my adjacencies are up, it's now showing this is site 2. And it's using the virtual tunnel interface to get there. And that is a NHRP route. And you can tell by, if you look up here at the key, here we go, next hop override right there. And that's the beauty of Flexvpn versus DMVPN. Is there a little bit more stuff to configure? Yes, but you can do IKEV2. You have the virtual interfaces. It does a lot of this seamlessly, and you'll just have their adjacencies. Now, DMVPN Phase 3 is great. But again, if you want to use IKEV2 and really want to take advantage of like the capabilities of IKEV2, on top of that have, AAA configurations for security purposes and stuff like that, this is why you would use FlexVPN. So that is FlexVPN in a nutshell. If you are studying for your CCNP security or CCIE security, you are going to need to know how to do this. You cannot get around this because they will ask you about this in the written, and you will probably see this in the lab. Now, I don't know for sure, but you got to be prepared for this to show up in the lab, right? Because they may tell you, hey, you need to do this, tunneling configuration, and you can't use DMVPN at all, and you have to use FlexVPN. You have to use IKEV2 to do it. That's what they'll say. You need to do, site-to-site VPN tunnels using IKEV2 protocol. And if you try to configure DMVPN Phase 3, and they'll say like, oh, and make sure you authorize it using AAA. If you try to use DMVPN 3 to do that, it's not going to work. It's not going to happen. So again, FlexVPN, hope you enjoyed this lab. Hope you enjoyed the fact that I'm using Cisco Modeling Lab. Cisco, I'll let your boy, man. I need a license. Don't forget to share, comment, like, and subscribe. If you want to see more stuff in CML, comment below too, man, because I know I got the free version now, but if you guys really want to start seeing stuff in CML, comment below. I'll get the license, and then we'll start doing more labs in this. All right. Thank you. Have a nice day.